Hi guys, I hope you are all doing well. Let's see today's question. So today's question is from the topic of determinants. And in this question, we have been told that determinant of these 9 elements is equal to minus 648 into alpha, where we need to find the value of this alpha. So first of all, let's understand how to solve this question. So first of all, I'll try to expand all of these elements. Then we'll try to understand what to do with the determinant. So if I keep it here, it's equal to minus 648 alpha. Now, first thing I can do is everyone is having a square of a plus b. So I will use the idea which we already know, that is a plus b the whole square. So we'll be using the idea a plus b the whole square, that is a square plus 2ab plus b square. So if I expand the 9 elements here, I get it as 1 plus 2 alpha plus alpha square. Next element, it becomes 2 square, so 4 plus 2 into a into b, so 2 into 2 alpha, that is 4 alpha plus alpha square. Next I get it as 9 plus 6 alpha plus alpha square. Further, if I expand these 3 elements, again a square plus 2 into 2 alpha, 4 alpha plus 2 alpha the whole square, I get 4 alpha square. Again, here if I expand it, it becomes 4 plus 2 into 2 into 2, so 8 alpha plus 4 alpha square. And here I get it as 3 square 9 plus 3 into 2 into 2, so 12 alpha plus 4 alpha. Next 3 elements, if we solve that also, 1 plus 2 into 3 alpha is 6 alpha plus 9 alpha square. Then we have 4 plus 2 into 2 into 3, so 12 alpha plus 9 alpha square. And the last we have is 9 plus 2 into 3 into 3, so 18 alpha plus 9 alpha. Now, one thing I can understand before solving the determinant also, that all of these elements have alpha square in common. All of these elements have 4 alpha square in common. All of these elements have 9 alpha square in common. So I can apply some row transformations to reduce my values of these elements. So I can take R2 changes to R2 minus R1. So alpha square will get cancelled here, and R3 also changes to R3 minus R1. So let's do that now. If I apply this row transformations, let's see what my elements become now. So now let's see what our elements become. Let's do that. So if I solve the first thing, first column, I get 1 plus 2 alpha plus alpha square remains as it is because it is in the first row. We are only changing second and third row. So second row, it tells us second row minus first row. So 4 minus 1, 3. And 4 alpha minus 2 alpha is 2 alpha. So 3 plus 2 alpha, and this gets cancelled. So you get 3 plus 2 alpha. Next, we have here 9 minus 1, so 8. And this becomes 4 alpha. This again gets cancelled. So you get 8 plus 4. Now further, if I do this, same thing here, I can do this. So 4 minus 1 is again 3. 8 alpha minus 4 alpha is now 4 alpha. So you get 3 plus 4 alpha, and 4 alpha square gets cancelled. 9 minus 1 is again 8, and 12 minus 4 is again 8 alpha. So you get 8 plus 8. The first term remains as it is only. So 1 plus 4 alpha plus. Next. Here I can keep it same, 1 plus 6 alpha plus 9 alpha square. 4 plus 4 minus 1, 3, and 12 minus 6, 6. So 3 plus 6 alpha, and this becomes 8 plus 9 minus 1, 8, and 18 minus 6, that is 12. So 12 alpha. Now, this is again equal to minus 648. Now, what I can do here, let's understand. Row transformation I can again apply is R3 changes to R3 minus R2, because I can see there is a pattern of 3 and 8, 3 and 8, 3 and 8, and this alpha is getting double, right? So I'll get it same then. So R3 I'm keeping it as R3 minus R2, and or else I can also write this as R3 minus 2R2. That would be beneficial because 4 alpha minus 4 alpha will make it 0 directly. So your third row will at least not contain alpha. And I can also change my R1 to R1 minus R2 because I can see this 2 alpha is common, 4 alpha is common, 6 alpha is common. Right? Let's do that. So if I do this now, let's see what I get. Now my entire determinant values changes too. So if I change my first row, it is first minus second row. So alpha square remains as it is. 2 alpha gets cancelled. 1 minus 3 is minus 2. Here I get 4 alpha square as it is. 4 alpha minus 4 alpha is 0 and 1 minus 3 is again minus 2. Here you get 9 alpha square as it is. 6 alpha gets cancelled. 1 minus 3 is minus 2 again. Now, further, if I try to solve this, second row is as it is because we are not doing any operations on that. And further, if I try to solve this, I get 8 minus 2 times row of 2. So 8 minus 6, it becomes 2 plus 4 alpha minus 4 alpha is 0 now. Here again 8 minus 6, 2 and 8 alpha minus 8 alpha is 0 now. So 2. Here also 2 because 12 alpha minus 12 alpha is 0. That's equal to minus 648 alpha. So we have tried to reduce our elements as it is. So now I can see here minus 2 is common in all three columns. 2 is also common here, as well as I can see here that 3 plus some value of alpha is common. So I can apply the column operations now directly. That let's say C1 changes to C1 minus C3 and C2 also changes to C2 minus C3. Now let's see what my elements become. So now I have my 9 elements as C1, so alpha square minus this, so alpha square minus 9 square, 9 alpha square is minus 8 alpha square, and minus 2 plus 2 becomes 0, so minus 8 alpha square. Then I have 3 plus 2 alpha and this, so minus 4 alpha from there, and 2 minus 2 becomes directly 0. Further, I have here 4 alpha square minus 9 alpha square, so minus 5 alpha square. Then we have this and this, so minus 2 alpha. And this I get again 0. And further, if I write that as it is, because we are not doing any column operations on this, 9 alpha square minus 2, 3 plus 6 alpha. This is equal to minus 648 alpha. Right? So now if I try to solve this further, let's understand. So now I can just find out the values of or the determinant because I have already turned out two terms to become 0. So let's do that now. So if I directly find the value of the determinant now, it becomes minus 8 alpha square into determinant of this. So minus 4 alpha and this is 0. Minus of minus, so plus 5 alpha square. This is equal to minus 8 alpha and this becomes 0. And further plus 9 alpha square minus 2 is multiplied with 0 because 0 minus 0 is equal to minus 648. So further what I get here is minus minus. So 32 alpha cube and this becomes minus 40 alpha cube is equal to minus 648 alpha. So that gives you minus 8 alpha cube is equal to minus 648 alpha. Alpha gets cancelled, minus gets cancelled. You get, we have got 8 alpha square is 648. And when I see this alpha square becomes 648 by 8, that is nothing but 81. And alpha square when it is 81, if I take the square roots, I get two values of alpha, that is plus 9 or minus 9. Now if you see the options here which matches in this question that is given to us, where we get the values of alpha, that is, so option here matches in this question is B and C because B is given to us as 9 and C is given to us as minus 9. So the correct answers in this question are both B and C. So alpha can be plus 9 or minus 9. So this is how we solve the question of the determinant which is given to us. First, we figured out all the elements and then we tried to apply some row and column transformations to reduce our elements. Once we reduce our elements, then it becomes easier to find out the value of the determinant and compare it and find the value of alpha. I hope you have understood how to solve this type of question. I'll meet you again tomorrow with the next question. Till then, you can like, share, and subscribe to my channel, and also share these videos with your family and friends. Thank you.